we'll multiply radicals. Alright, so to multiply radicals, let's say we're multiplying a single radical expression by another radical expression. So let's say we're doing 3 square roots of, let's say it's 3 square roots of 5 multiplied by 7 square roots of, let's say 10. Let's say this is what we're multiplying. Well, each one of these radical expressions has a rational factor multiplied by an irrational factor. For instance, the 3 square roots of 5, 3 is rational, you can count to 3. The square root of 5 is an irrational number. And the second one, 7 is rational, and the square root of 10 is irrational. The way we multiply them is we multiply the rational factors, the 3 and the 7, because we know that product of 3 and 7 is 21. And then we multiply the irrational factors. Well, to multiply the irrational factor, there's a little rule that we're using. The product rule for radicals says as long as the nth root of A and the nth root of B, as long as they are real numbers, they have to be real, then the nth root of A times the nth root of B is equal to the nth root of AB. So as long as they don't involve the imaginary unit, then when you multiply two radicals like this, you just multiply their radicands together. So we'll get the square root of 5 times 10, the square root of 50. But after we do that multiplication, then we still have to simplify. To simplify this, we'll get 21, and we'll break this up into the square root of 25 times the square root of 2. So we're factoring that square root of 50 into two factors. You notice that one of those factors is rational. So this is going to be 21. The rational factor is the square root of 25, which is 5. And then we still have the square root of 2. So then the last step is to just multiply those two rationals. Let me see, that's going to be 5 times 21, 105 square roots of 2. So that's how you'd multiply two single radical expressions by each other. Alright, let's try to multiply a single radical expression by the sum of two expressions here. Square root of 15. Let's try that one. Multiply is what the directions are on this example. Just multiply. So let's multiply. Well, this would be the distributive property, obviously, right? So I'd multiply this by this, and I'd multiply this by this. Well, in that first product, this is a rational number too, while this is irrational. So I keep the rational number and I just multiply it by the irrational number by putting them side by side. On the other hand, both the square root of 5 and the square root of 15 are irrational. They're both under radicals. So that product rule says as long as they're both real numbers, and they're both real because there are no negatives. We're not taking the square root of any negatives. So as long as they're both real numbers, I can multiply them by just multiplying the radicands. So I'll get the square root, and then 5 times 15 is 75. 5 times 15 is 75. And then we simplify and see if we can combine them as like terms. So to simplify, I can factor out the square root of 75. Let me see. There are some factorizations that I can consider. I can consider the square root of 25 times the square root of 3, or the square root of 5 times the square root of 15. That's pretty much it. Well, the only one that has a perfect square factor is this top one. So I'm going to use that one, and I'm going to break this down into the square root of 25 times the square root of 3. So my final answer then will be 2 square roots of 5 plus that rational number is 5 times the square root of 3. And since those are not like radicals, they don't have the same radicand, this is how I leave my final result. So that's the final answer for that. So that's how you'd multiply a single um, radical expression by the sum, by a sum. And then let's see, what if we had something like this? Let's say it were multiply, and it were the square root of, let's say, 7 minus the square root of 3 times the square root of 2 plus 4. Let's say this was it. Well, this one I don't know if you see it, but this is a FOIL question. We just have to make sure to distribute both the 7 to both of these, and also distribute the the square root of 7, I should say. We're distributing the square root of 7 to both of those, and we're distributing the negative square root of 3 to both of them also. So let's do that distribution then. The first two, the square root of 7 times the square root of 2, I multiply the radicands to get the square root of 14. And then the square root of 7 times 4, one of them is rational, 4, the other one irrational, square root of 7, so I just leave them that way. And then for the second two now, when I'm distributing the negative square root of 3, negative square root of 3 times square root of 2 is negative square root of 6. And then negative square root of 3 times 4 is negative 4 square roots of 3. And then you look at them and you see if you have any like radicals or any radicals that can be simplified. And indeed we do not. The square root of 14, you can't break that up into anything but the square root of 2 and the square root of 7. Square root of 6 is just the square root of 2 and 3. None of those are rational, and the other two are actually prime. Let's try one more. Last one. Multiply. And let's try the square root of 10 minus 7 multiplied by the square root of 6 plus the square root of 5. Alright, let's do this one out here. Alright, so we're going to distribute once again this to this and this to this, and also we have to do the other one. We have to do both distributions there. So the distribution of the square root of 10 gives me the square root of 60, and it's going to be plus the square root of 50. Okay. And then the distribution of the negative 7 gives me negative 7 square roots of 6 minus 7 square roots of 5. And then I just have to simplify if there's anything that can be simplified. I see here that I have the square root of 60 that I can break up. Let me see what perfect square goes into 60. 4 goes into 60, right? Or does it? Yeah, 4 times 15, right? So I can break this up into the square root of 4 times 15. And 25 goes into 50. So I can break this up into the square root of 25 times 2. And then, let me see, 6, once again, we cannot simplify any further. And 5 is prime, so we don't have to simplify that anymore. So we get 2 square roots of 15 plus 5 square roots of 2 minus 7 square roots of 6 minus 7 square roots of 5. And that would be the final result after simplification.